we were trying to find things that that Arvind and Sayash and Daniel and Eli and Thomas like strongly disagreed upon in the next couple of years, and found it like actually somewhat challenging. And so what we're going to do is we're going to have two sessions back to back. In the first session, we're only going to talk about things that they agree about. So okay, on one hand, a book titled AI Snake Oil and something called AI as a Neural Technology. On the other hand, something called AI 2027. You might think that this means that the intersection is very small. It turns out it's actually remarkably large. And I'd like to just like spend the next little while focusing on, yeah, exactly the things that they agree on. Hopefully the first 30 minutes or so will be things that we can just have them talk, and then there will be plenty of time for questions, followed by a break. I will make notes every time they disagree and then tell them to stop disagreeing. And all of that will happen then in the next hour, where they will have lots of time to argue with each other. My presumption is that most of the people here have already read AI 2027 or seen something like it, and have already read or have seen something like AI as a Neural Technology. So I will also stop them if they're explaining their works that they have already written. They had a very similar debate last year, and I don't want to just to have the same debate again. So sort of if you haven't seen exactly their arguments, hopefully you can just sort of keep up from sort of maybe 50% of the way through. So that's my hope. I don't just want to repeat things that we've already done. Okay, so with that started, I think one potentially good, useful thing to start with is where we might end up. So I think, Daniel obviously thinks that at some point, possibly soon, we will have machines that can do everything that humans can do economically, only like, better, faster in every way. And I sort of want to start with, Sayash. In principle, you roughly agree with this as a thing that is possible.
Absolutely. Yeah. So I think one of the things that I feel like people often take away from AI as normal technology is to say that there's like a strong upper limit on the capability of AI or any other technology we can build. I think that's definitely true in terms of how quickly we think we'll get there. But in principle, I think there's no like the AI as normal technology framework assumes there's no upper limit to the capability of AI systems. So this includes everything that you just talked about.
Including like a whole country entirely run by AIs, entirely run by robots, entirely self-sufficient, growing at some, rate based on the technology, no humans involved.
So, I mean, like, I guess I would distinguish between two different things, what is technically capable and what is economically valuable. And I think the way we define things as being economically valuable, and this is almost tautological in my worldview, is like things that we essentially cannot yet automate away. And as soon as we automate a particular task, its economic value drops very quickly. And so, in some sense, this country wouldn't be like an independent country as we think of it today, but it might be like a warehouse that's run completely independently and autonomously by AI systems.
Let me just see if there's agreement on this, that at some point in the future, you'll be able to fully automate AI R&D in the sense that if you took all the humans and you're like, sorry, you can't show up to work anymore, productivity would decrease by less than 5%. Are you like, that's not going to happen? And I'm like, maybe that means AI R&D is extremely cheap now. Fair enough. But
Yeah, I think basically the way we define R&D will change to be about anything the AI systems can't do. Or like AI systems will be an essential component of what we do. For example, like today we don't think of writing assembly code as like a skill that I need to have as a programmer. It'll be very similar. I mean, everything that we can use AI systems to do.
okay, I still can't tell if we agree.
No, I think so. At some point, you agree that, like in principle, like if you like disappeared all the humans from the face of the earth, the rate of technological progress would still continue exponentially. You would like suppose we sort of are like roughly where we are today. We're like constrained to the earth. You think that it exists at some point in the future, maybe let's call it 100 years from now. If you sort of disappeared all the humans, the models would be able to continue the rate of progress that humans were seeing. Maybe there's no more humans to like have as like therapists, and like people would prefer other therapists, and that's where you had previously some economy there. But like the like rate of technological progress, like you maybe agree that they would be able to like get us a Dyson sphere or colonize the stars or whatever.
So like, yeah, in principle, I think we can get to technology that works autonomously
Yeah.
in this way. And like, I think what I would disagree with is whether adding humans to the loop or like humans having come up with these technologies or having control over them will lead to better or worse outcomes. And I think like that I'm still not sold on.
Better or worse technologically, or like from as far as like we like I might prefer one world to another.
Both.
Okay.
Can you say more about the technological part of it? Like, So are you saying that like even though in the future perhaps there could be like Robo Australia that's has no humans in it and is full of robots digging holes and making factories and things and launching, rockets into space to colonize Mars. You think that like Robo Australia would be like colonizing Mars slower than it would if there were a bunch of humans helping out?
Exactly. Or like the space of things that we would be constrained to might be a lot smaller than the space of things we might be sort of exploring had we had like certain other inputs.
Do you agree that there exists, suppose we just like magically transport AI systems back in time from some point in the future, there would exist AI systems and a set of robots such that the humans would be adding negligible value in Robot Australia?
I mean, like maybe for the first 10 years, sure. But I guess we would figure out.
Indefinitely. Like it's like indefinitely the case. The humans are just worse, right?
Yeah, I mean, I think the way we define these outcomes is in some sense based on human
In
preference,
terms
right?
of like amount of energy they can harness. Like, let's say they just want to compute more digits of pi. They just want like a big computer to compute more digits of pi.
Yeah, so on building like better compute, like sure, but it might turn out, for example, that we need like to invest in new areas of science we think wouldn't even be possible without having certain kinds of exploration that we might want and value more than building more computers.
This is getting remarkably close to some disagreements I found.
Okay, I can't tell.
Um,
I still can't tell if we disagree.
I mean, I think okay. So at least the
Think
like,
so?
yeah, okay, but in some potential very far future, like you're sort of you're with them up to the like it could do like extraordinary sort of like things.
Things that we deem extraordinary today. Absolutely.
Yeah.
No sort of qualms there at all.
Okay, so let's sort of flip to the alternate sort of side of this, which like in the short term, I think one thing that someone could read looking at AI 2027 is like, by let's say 2028 or something, that like clearly the models will like be able to like reliably book me flights. Like if I like ask it like, get me a flight to Paris, like one thing someone might think is like obviously that you would think that this is the case. But when we have talked before, it seemed like, you do have some sort of like probability mass assigned to the possibility that models could be like, amazing in many, many ways, but still like have mundane failures that like are kind of obvious. Like, yeah, I think you agree with this roughly.
It's possible. I think probably they'll be able to book flights in 2028, but like
But you
maybe not.
wouldn't strongly disagree with the statement that like, like you wouldn't put, I don't know, 10 to 1 odds that like, that you can reliably.
Correct.
Yeah.
But and this is because my timelines are just generally kind of uncertain. Like maybe it happens in 2027, maybe it happens in 2033. Like I have a distribution over like possible years. I do think it's probably going to happen in the next decade. I would even maybe say probably in the next 5 years, but it's like 50, more like 50, 55% probably instead of like 70% probably.
Okay. So I think it was sort of was like I wanted to like go on either extreme. Like, there was like on the short term, there's like potential that the models are like, not doing very much. Like they'll, like have sort of mundane failures. In the long term, potentially things are going great. Okay. Let's sort of maybe I think that you wanted to do is okay, like let's start year by year and be like, okay, like do we sort of roughly agree with things for how you imagine they're going to play out in like 2026, and let's sort of like go year by year and see when we get to the point where we disagree, and then that will be shifted to the end, and then we'll sort of continue from there. So okay.
Sounds good. So my guess is that we kind of don't have any disagreements about like the next year. Probably.
I don't think so. Yeah.
What's gonna happen? Like I can
So,
say
like,
some
so,
stuff.
yeah,
Yeah, let's get some
List
detail.
a couple things.
The AIs are going to get better at lots of stuff. The meter trend in particular is going to continue. We'll see like another 2 doublings in horizon length on coding tasks as measured by meter, something like that.
Yeah, I certainly think all of that is plausible.
Yeah. So you think like concretely like if there will exist some language model that I can give a programming task that today would take a human like let's say 8 or 5 or like 10, 15 hours, potentially like a couple of years, maybe like one year, maybe or maybe eight might be a little bit too far, but
We should expect roughly 8 by the end of the next year on benchmarky tasks.
sure, okay, yeah, so like you think it's conceivable that something that like would have taken me a day of work to do, like I could just like push go and come back to the model in an hour or two, and like it just has the results for me.
Yeah, and I mean, like to be clear, I guess the distinction I would make is between doing this on benchmark tasks versus doing this in a way that's like extremely reliable that you could almost push to prod as soon as you get it back.
Sure.
So I still think you would need lots of human validation and verification at the end of it. But yeah, I mean, right now, if I use like Claude Code for tasks that might have taken me, I don't know, a couple hours, maybe I would have doubled it twice, and like we would have got into 8 hours of like unreliable, but and still needing human verification, but like we can do much sort of more ambitious projects using coding agents.
Okay. What's the next thing that you expect?
This is a little bit dangerous because we might disagree about this, but what about coding uplift? So there's various uplift studies that try to measure like how much faster are coders doing actual real world coding tasks with and without AI assistance. My guess is that those numbers are going to they're fairly low now, probably like maybe 20%, maybe lower, but they'll sort of gradually rise over the next few years.
-20%.
Or minus, yeah. I don't think they're actually minus.
What about maybe we should distinguish between like within AI companies, random open source developers, like maybe
within it? Ideally, I care about what's
let's say within AI
companies.
companies.
Yeah.
Okay.
So I bring this up because you mentioned the gap between benchmarks and real world, and this feels like more of the real world thing of like actually in the AI companies, how much faster are the programmers working compared to before, or compared to if they didn't have access to the tools.
Right. And I guess like here, I think on the specific aspect of like writing code, I think we would get a lot faster. In fact, even for the meter uplift study, I think we had access to like a pool of developers who'd spent, I don't know, like 2 weeks of full time using like Cursor or more sophisticated agents, or like I guess even not 2 weeks, like maybe a month or two, because I think that's the sort of learning horizon for really figuring out how to use these tools well. The results would have been drastically different. And so I think that's already true today. And I think at the specific task of like writing code or figuring out like what specific experiments to run, absolutely, like every individual programmer would be much more productive. I guess the place where I differ is what impact this has on the pace of AI progress. So, for example, I think there are many bottlenecks beyond just developer time at improving or increasing the pace of progress. One of them right now, most pertinently, is access to compute. Like I think most labs are already compute constrained. So no matter
We'll return to that later.
Yeah.
Okay. Go.
Yeah, so I guess I just to put out some numbers we can disagree with. So I would have said that like
We can agree with.
agree with sorry maybe maybe I would think that like research engineers with respect to the like let's say we imagine a research engineer at Anthropic, let's say, who's doing work that's centrally research engineering. I would guess that they are currently operating around like 25% or 30%, all considered increase in productivity. Like it's as good as though they were running that much faster. That'd be my guess. Maybe you have a better idea. And then I would have guessed that 1 year from now, that number is instead like 80%, like 1.8x.
I mean, again, that's true for the time they spend writing code, but
I meant their whole job, like as in the job of someone who does research engineering, which some fraction of it is going to meetings, some fraction of it is writing code. And like this will include things like they maybe write more code than they used to because it's now cheaper, etc.
so I strongly doubt that simply because of these other bottlenecks. I think like as we become more productive.
So what would
right-
be the number that you would agree with that like yeah.
So I doubt it's 25 to 30% today.
And to be clear, I meant that's the productivity improvement on specifically a research engineer. Like it's as though your research engineer is like 25% faster. Obviously, that doesn't mean AI progress is 25% faster because of other bottlenecks.
Yes, I think it would be close to like the 25 to 30% based just on vibes. I guess we'd have to measure that more closely. Like at the end of next year. And right now I have like trouble even figuring out what is the sort of blocking factor for conducting better research experiments. Like sometimes it's not just writing code, it's like coming up with new ideas or like expanding the space of things you consider is important and so on.
Yeah. And I would also say that maybe I expect that maybe a year from now, like 1.5 years from now, roughly, I expect like AI R&D has been accelerated by AI by all considered AI R&D has been accelerated by AI, maybe like 10 or 20%.
Interesting. Yeah, I think I would have, I mean, so maybe coming back to like AI R&D from the individual engineer, I think actually there's,
I meant the whole company. It's like
Right.
Anthropic is they're now doing better. They're developing better algorithms at a 10 to 20% faster rate.
yeah, so I think like that is something where I might strongly disagree with. So maybe we could
Okay.
put
Yeah,
it in the next part.
yeah, okay.
But like again, because like collective progress, I think might even slow down as individual progress increases. Like we might be focusing only on the small number of problems that are amenable to AI generated code. We're not thinking of paradigm shifting improvements and so on.
But so in my understanding of your agreement on the like they can write code better or the help with code is I am much faster writing a program in Python than I would be if I was writing an x86 assembly.
Exactly.
And your view is, in the same way that having access to a compiler speeds me up, the fact that I now have some language model that I can interact with, it will speed me up in some amount. Like a compiler to x86 assembly might be, I don't know, like a factor of 5 for me.
Just 5? Wow.
uh, okay, but I don't. Okay, whatever the number might be. Yes. When I used to do security, I did. But okay. Yeah. Okay. No. Okay. So whatever the number is, like there's some large number there, and your view is like 20% at least, sort of for language models sometime soon.
Or even more, maybe. Like for the specific task,
Yeah,
even
yeah.
more like. But for the general task, the general job, I think
Okay.
it's 20%. The specific task could be double or like even more than that.
Okay. So like on the order, roughly like having access to a compiler or something like that.
Exactly.
Yeah. Okay. Okay. So good. So this has been the first 20. Oh, you want to respond?
Maybe we should do another year,
Yeah. Okay. Sure.
2027 or
Yeah, sure. So it seems like we're all basically like, yep, the trends are going to continue. And then it seems like at some point, maybe 2027, maybe 2029, whatever, something like that, I think that you get something like full automation of AI R&D, and it sounds like you don't think that.
Yeah. I think that's where we.
can we do? Come on, guys. Let's do some agreements here. Okay, maybe I can.
So
You can do revenue trends. Do we think the revenue trends continue? Like revenue, I would say, is like roughly tripling each year across the AI industry, at least over the last 2 years. Obviously, it's not a very long trend. Do you think that's going to happen again in 2026? That's like roughly my expectations. That would be like around maybe 60, 70 billion across the whole AI industry, or like core AI companies.
Yeah. I wouldn't be surprised.
And like it was sort of going forwards a couple more years, so you say AI is normal technology, but in some sense, Google is a normal company. You can imagine that the biggest labs are worth low trillions of dollars.
Exactly. Yeah. Like that wouldn't again be. It would be like a sort of low probability event, but I think.
But like you would not confidently refute that
Exactly.
this was potentially true.
what does your central trajectory look like? Like, let's say in 2030, would you say, like, my guess is that you would say that the companies aren't going to sustain an average of tripling revenue for the next 5 years. It's going to taper off. How fast does it taper off according to you? Probably.
I think it's very hard to predict. And I think this is like one of the differences in worldviews, because in my worldview, the reason this tapering off happens and the reason like the revenue growth continues is because of diffusion. And so I think we're bottlenecked in this increase on diffusion. Like how quickly can we automate or augment humans or increase their productivity across a wide number of tasks? And so coding is like the first example where I think we've started seeing like strong early examples of diffusion. But I think the way it happens for the next few orders of magnitude of revenue growth is by going into healthcare and then going into education and finance and so on. And I think the reason it's hard to predict is because that question is independent of the state of the technology. Like in some sense, if we were to diffuse current AI systems across these domains in a productive way, that might already be enough. But it's hard to say when that will happen because it depends on like finance companies being sort of comfortable spending a lot of their time on developing new scaffolds for these existing models.
I agree. It's hard to predict the future. We definitely agree there. And I have lots of uncertainty too.
Okay, so I think that's probably roughly the point at which like in your sort of median timeline, like the next year is like takeoff roughly.
So like we have a timelines model that we're working on at Futures Project, and it tries to take into account all the variables that we feel like are important. And one of the like interesting things about it is that it does account for it does like allow for or predict the possibility of a slowdown around the end of this decade. So like we can do like a Monte Carlo of a bunch of trajectories, and some of the trajectories look like this, and then like sometime in the 2030s go like this, right?
Okay, so yeah, so it's like you would if I told you, it's 2050, I'm a historian writing the books, in 2030 there was like, a slowdown where, for some reason, like we were not having Dyson steers soon, like, you're like, this makes sense to me, like, yeah, this seems right.
What I would say doesn't make sense is if we fully automate AI R&D and get super intelligence, I would then be very surprised if it takes another 30 years to get to crazy stuff like Dyson swarms.
Yeah, maybe trying to push for more aggressive agreements. So like, what about the probability of like substantial increases in GDP growth due to AI? Let's say before AI R&D is automated, right? So we know we start disagreeing once that point happens. What about like, let's say probability that the that GDP will be growing, like there'll be like 1% of additional GDP growth in the US due to AI in like 2029, 2030.
Very plausible.
Okay. And what about like, yeah.
I don't think we're gonna get 1% GDP growth today.
This is a fun one.
Is that really like wait? Would prior to automating AI R&D?
Yeah, I think it's pretty plausible. I mean, so it's worth noting that
Like-
once you get sufficiently, here would be the basic case in favor. Suppose AI companies cumulatively have like $1 trillion in revenue. At that point, that is literally like, what is that, 5% of US GDP? And so if you think that there's some multiplier on top of that, even it actually can you're already at a point where it's starting to contribute substantial amounts to GDP there. But that would be the case in favor. I mean, we can talk about the case against, but
I guess I'd want to look at the revenue numbers and stuff. But we said next year, right?
no, I said
Oh,
before
2030.
like let's say like before 2030 without AI R&D being automated.
Yeah, I guess I'd want to look at the revenue numbers and then see.
Okay, so let's go do one more different thing for like maybe 10 minutes, and then we'll come to audience questions.
Sounds good. I could say a spicy thing, which is that I think that prior to AI R&D being almost fully automated, AI is basically a normal technology.
Yeah, no, I think this is roughly yes. Yeah. In the sense that
Like in the senses you've described. Like I think that like that's kind of how that is how most technologies work. That is also how AI works. Up until the point when it's intelligence explosioning, and then you get the really crazy stuff.
and we will have an hour
Yeah.
to talk about that. Okay, so let's talk about some things that we agree on, not necessarily even coming from different worldviews, but like the implications of this. So one that I think was interesting to hear just very recently was that you both agree that like the diffusion of the technology is good, and like you would rather live in a world where the like technology was like maximally available to everyone roughly simultaneously, to one where the models were like much better for only the people doing the AI R&D in the labs, and like you prefer that world, which in particular implies you both like open source models.
Yeah, definitely.
Perhaps we could talk about this a little bit. You want to start?
So, I mean, like to me, it seems like the main consequence of the normal technology worldview is that we need to focus a lot more on diffusion. Like a lot of our efforts need to be on figuring out how we can productively diffuse this technology across different sectors of the economy. And that will be the main reason why we'll continue to have revenue growth at AI companies, but also the main benefits of AI will materialize through that. And so, like, in some sense, the main consequence of the normal technology worldview is that we need to focus a lot more on diffusion than we are today. And maybe even the fact that, like, the corollary being like, we are almost focusing too much on building better models and not enough on the diffusion aspect right now.
For what purpose? I'm curious. So I understand the general point of like, if this is just generally what's more important, then regardless of what our goals are, we should be focusing on this. But I'm curious to what extent you're thinking things like, if we want to make lots of money and reap lots of benefits, we need to focus on diffusion, versus things like, I'm really worried about the following risks, and the way to stop those risks is by focusing on diffusion. And I'm curious to hear more about.
So I think it's both. So for the latter point on what risks it can prevent, it's definitely like concentration of power. That is something we've seen like monopolization of. And even in the world where like AI does not, or AI companies don't just form like a monopoly or a duopoly, I think that's still sort of important to figure out how we can get as much access to different kinds of models as possible, because again, it'll drive like diffusion much more quickly. So for example, in the case of cyber defense, I think blocking down models that are really good at cyber offense will be net bad for cyber defense, because we can't also develop applications of cyber defense. And the engineers at companies have much better access to the systems they're trying to defend. And in the past, like offensive cyber security tools have been very, very helpful for cyber defense as well, such as fuzzing tools.
Here's a question for you. So I share your concern about concentration of power, and I'd love to actually vibe about that for a little bit. Let's consider three worlds, which I think we'll probably agree in terms of like the ranking. So in world 1, there's a bunch of AI companies, and it's a relatively competitive market, and no one of them has like a huge amount of market share. And there's a bunch of like downstream, application companies that like, buy API services from the AI companies, and like there's like lots of like model weights being hosted. Like there's lots of like open source models and things like that. But that's very diffuse, right? In world 3, there's basically only one company or consortium or United States mega project, and it hasn't had much diffusion happening yet. It's been doing the intelligence explosion-y thing. It's got this amazing stuff internally, but the rest of the world looks mostly the same. And it's like ready to like burst out into the world. And then in World 2, it's sort of like the situation. Well, in World 2, there is a lot of diffusion, but it's still sort of like a monopoly at the level of model providers. So there's maybe one or two big companies that train the giant models, and then there's loads of diverse companies that like use the API to do all sorts of cool stuff in the economy, but like the models themselves are controlled by one or two companies. My claim would be that like World 2 is more similar to World 3 than it is to World 1 as far as concentration of power is concerned. And I'm curious if you agree with that or if you think it's more similar to World 1.
Yeah, I think like I do think it's more similar to World 1. In some sense, like that is where we are at other levels of the AI stack. For example, like fab manufacturing or chip manufacturing and so on. Like we have this monopoly or duopoly. And I think it is possible that we move into the world, although I do think it would be bad from the perspective of diffusion, but it's possible we move into the world where like this sort of monopoly extends one layer up the stack. And that would be bad.
Yeah, so it seems like we have a disagreement to talk
Yeah.
about like where what are like the nodes of power in the future world, so to speak. Like I think the people who control the model spec of the models that everyone's using are like that's where the real power is. And yeah.
Yeah, I would say like on this whole like diffusion topic, I think there's two different stories for why you might think diffusion is good. One is like normal economic benefit. Another one is like having the world understand what the fuck is going on. I honestly don't think the normal economic benefit matters very much because I think we'll get dominated by later factors, like both risks and benefits. And I'm like most care about the like people knowing what the fuck is going on and being aware of the situation. And from that perspective, I guess I would have been like, yeah, the concern would be like, you know, external deployment being well behind internal deployment. I don't think that clearly suggests open source good. I think it's kind of a messy picture. For example, it really depends on how you trade off like biorisk with like alignment research, which like I feel reluctant to be like, yeah, we should just eat a bunch of biorisk because we'll get out some like alignment research and more awareness. I'm like, man, that really feels like a brutal bargain to be striking, and I don't feel like I want to be advocating for it. But I also am not necessarily going to advocate against because I think it's kind of unclear how the calculus works out. Yeah.
Well, let's take this and go to one other thing I think you both agree on, which is alignment, at least as of right now, is like unsolved and needs a bunch more work to be done.
Agree, like hard agree on the first part, maybe ambivalent on the second. So like I definitely think like alignment, like today's models are misaligned or unaligned or whatever, and we can't trust them to make like consequential decisions. I guess the consequence for me is we need to work a lot more on ensuring orthogonal systems of control rather than just making sure we solve alignment and sort of, in some sense, maybe it's like a more conservative view than Daniel's for once, which is if alignment is our last line of defense, then we're fucked, basically.
Here. Agree with that. Have you talked to Buck and the Redwood people about AI control?
I don't think I have, no.
Okay.
Okay. Well, we could talk about that at some point. But yeah.
They are also thinking something like we need a second line of defense of like, models monitoring other models and like security, stuff like that.
I guess one thing where we should like note for the next session is I think this process will by default come about because of a mix of market incentives and policy making.
Yeah, so there's probably some disagreement there. I think my view is like, as AI companies are internally deploying their systems, it would be in principle possible that they make it so those systems would have a very hard time causing huge problems. And that this is also not necessarily that likely to happen. Like it might happen, it might not happen, and it might be like a big pain because of things progressing extremely fast, huge incentives to deploy quickly. So like for example, I would say right now, here's like a concrete example. Let's say I backdoored 4.5 Sonnet using the pre-training corpus, as one can definitely do. I think it would be not that hard for me to then cause that model to, let's say I like maybe even did a very sophisticated backdoor, like figured out exactly how to do this. I could make that model suggest code edits that are like pretty obviously malign, and there's a reasonable chance those would just get accepted and merged. But like they probably wouldn't be like, that bad because the PRs get reviewed, whatever. But like in practice, people do accept like all kinds of like bash commands, whatever, without really looking at them very carefully right now. And you could cause a bunch of havoc. Do you agree with that?
I mean, I guess sure, but I guess the solution in some sense for me is to sort of shore up defenses in terms of like better peer review or better infrastructure.
Sure. But you were saying that people will do this by default. And I was like, it's not true now. Do you agree it's not true now?
So, I mean, okay, so in some sense, like, here's a story from the time when I used to work at Meta. I guess we had lots of SEVs internally, and, you had like a SEV 0, SEV 1 classification for what happened. And I think for most SEV 0s or SEV 1s, there was like this sort of proximal cause of it. Someone checked in a bad PR or whatever. But the solution was never to fix that proximal cause. The solution is always to harden the infrastructure so that one engineer who has sort of not had their morning coffee cannot check in a bad PR. And I think that's the approach we should be taking to this type of risk as well. Like, it can never be on every individual software engineer to sort of not check in bad code, but the systems that we build have to be robust to this type of thing. And that's why I also think like diffusion is important, because it gives us the time to deal with and come up with these system level defenses that can defend against this type of risk.
Yeah, so I'm going to agree with that, but then maybe there's some disagreement about, well, suppose that all the AI systems are misaligned and they're writing all your code, then how do things go from there? And this is actually disanalogous to like one engineer doing whatever.
Sure,
But
let's
yeah,
talk about that.
but let's talk about
Okay, so maybe one. Oh, go ahead.
I was also going to say, I wonder if part of where we're coming from here is a difference in timelines to the really crazy AI stuff. Like, I think that market incentives and these feedback mechanisms and stuff totally exist. And they tend to like, I would say they tend to operate over the span of like several years. Like some company messes up, gets in lots of trouble, goes out of business, other companies adjust. And so I think that like, prior to the intelligence explosion, while the AIs are like not tremendously more capable than they are today, we'll be in that sort of like normal regime where, there'll be this gradual hardening of the world as people learn from experience from the various misalignment failures that they encounter. And perhaps now I want to see if you agree. Would you agree that like if something like AI 2027 happens and we get the like explosion of AI capability coming out of a company, like what happens in Open Brain and so forth, and now we have the super intelligences that are just better than humans at everything, basically. Would you say that in that situation, if that really does happen in 2027 or 2029, that like ordinary market forces are just going to be wildly inaccurate or wildly inadequate to like harden the world against that sort of thing, and like, we're fucked, you might say,
I mean, I guess like it's a big if, but I guess like if we sort of condition on this thing happening, I mean, like maybe to say something analogous to what you said, that's not a normal technology, I hope, and that's like obvious. But B, I do think that's when we need to take sort of really drastic measures. So like beyond just market incentives, for sure.
Great. Okay. Then maybe last point of agreement. I think that's kind of easy, but both you had noted this that you agreed on. Transparency, auditing, reporting, good in all possible worlds.
Yeah.
I'm a philosopher, so I won't say all possible worlds, but basically, yeah.
Okay. Great. We now have roughly 15 minutes or so for questions. So yeah, I
Hi. Okay, I'm Nilufar. I have a question that is twofold about diffusion. You guys agree that it's necessary. Is it necessary in terms of we would open source things and make it available and let people adopt it in other countries, or we would go out of our way to make sure they do adopt it? Because we are in a bubble in Bay Area, and then there's a bubble in the US, and then there's like a first world bubble. But then when you go to countries, Latin America, Middle East, whatever, it's very different, right? So you have to go out of your way to get them to adopt it. So in your sense of diffusion being necessary, is it that we should go out of our way and make sure everyone does it or not? Or is it that no, we'll just let it be there and then people adopt it? That's one thing. And this ties into this. I don't
let's
want
answer
to
the first question first.
Okay.
Yeah, so I wouldn't have said diffusion is necessary. I would say that diffusion, especially to people in positions of power, makes it more likely that society handles the technology reasonably due to more awareness. And so I would actually say that diffusion to like the Middle East is much less important than diffusion to like, for example, within the US government or to like various people who might be influential in other ways so that they like understand what is coming.
So, I mean, I would say like, yes, definitely to the first point, we should not erect barriers to diffusion because I think that'll be very counterproductive. And then normatively for the second point, I guess I don't have a position on who should be doing this, but maybe like, for example, if you're like a government leader in Latin America, you should definitely be thinking about how to enable diffusion. So like not necessarily the people in the room, but people who have the decision-making authority should definitely be thinking about how to diffuse these systems better.
Okay, so it's not on us to make sure other people adopt it.
I guess not. Yeah.
And then just for you, because you mentioned that you think it makes it more robust if more people are. This might be controversial, but with nuclear, also people have shown that if more countries have nuclear, it's actually a safer world. Do you think it's the same thing or not?
I mean, I guess I see AI as like a very different technology from especially from like nuclear weapons. So I guess it's more analogous to nuclear power in some sense. But like for nuclear weapons, you have very strong observability. You have sort of immense, I mean, much stronger than AI for sure. So I mean, and then you have like a very specific threshold of when a country has built a nuclear weapon or not. Like for AI, I think it's not so black and white. And so that's why it's important to have this kind of sort of regime where people can actually build these systems and figure out in low stakes settings how things can go wrong and then continue to shore up their defenses as the models keep getting better.
Thanks. Gideon Litchfield. Could you explain a bit more what you mean by automating AI R&D? Because the way I understand it is LLMs building better and better LLMs. And if that's what you mean, then that implies you think LLMs are the be-all and end-all and will eventually be capable of everything. And if so, why? Otherwise, it means LLMs helping to do some of the other directions we're seeing in research, like embodied AI and neurosymbolic AI. And if so, what makes you think they're going to be capable of advancing that on their own?
So it depends on what you mean by LLMs. I certainly am not saying that automating AI R&D is LLMs making better LLMs or whatever. Like, I mean something like everything that OpenAI is doing, everything that Anthropic is doing, the whole stack, including searching for new paradigms. I'm saying when all of that gets automated and the humans are no longer usefully contributing.
LLMs are capable of doing that.
The question was, you think the LLMs are capable of that?
It depends on what counts as an LLM. So I think that like probably they'll need to have some improvements in online learning in order to be able to do that. And they'll obviously need to be like a lot smarter across the board than they currently are. They'll have to have much longer horizon lengths and better memory management systems. Possibly all of that still won't be enough and there'll be additional stuff needed. But maybe that'll be, I think that'd be like my median guess is that like that package of things will be enough.
I think you also would agree roughly with the like more things will need to be done also with like LLMs by themselves are sort of insufficient.
Yes, absolutely. I think we need new paradigms. And I guess to me, it's unclear whether AI being used for automating AI R&D helps or hurts even. Like not even that. It sort of definitely helps.
Yeah, and we were just, the last talk before this in one of the other rooms was Gary Marcus, who also said like 3 to 5 leaps are needed, like, LLM's not enough, but like more things.
And I could just add, like, if they're not helping with the search, if they're not automating the search for new paradigms, then they haven't automated AI R&D. Like the search for new paradigms is part of the AI research process. And so I have a sort of high bar for what counts as automating AI R&D.
Okay. Well, let's bring the mic forward.
So you talked a little bit about the difference between, say, performance on benchmarks like the meter benchmark versus real life. I'm wondering if for each of you there is kind of a sense of a penalty. Say, if you can do 8 hours in the meter benchmark, you might be able to do 8 divided by C hours on real world. What do you think is C? And also, if you wanted to do it like reliably on most tasks and not just on the median task, is there another factor? So what is kind of your penalty factor of translating from benchmarks to the real world?
I guess this
Yeah.
first assumes is a sort of constant division, which maybe you.
Or maybe you don't. Yeah, maybe you
But
think
I
there
think
is a difference.
Sayash is probably going to refute the fact that it's a constant.
Yeah.
Yeah, and I mean, it could be strongly negative. So, for example, we've been running evals on agents that sort of do real world things. And there's this nice benchmark by the folks at Sierra AI called Tau Bench, which requires people to do things like book a flight or do shopping and so on. And, like if a web agent sort of solves the task incorrectly, it gets a 0. If it solves the task, if it abstains from solving the task, it gets a 0. And so you might think, oh, today's web agents have like a 56% accuracy or 70% accuracy on Tau Bench. But if you actually dig into the failures a little bit more, and we've been doing that with all of the agent logs, the agents do things like booking flights with the wrong credit card, or booking the wrong flight, or booking business instead of economy, or refunding the user $6,000 additional dollars. And so if you come up with metrics that actually get at what the economic utility of these agents is, I mean, it's extremely negative right now. So like, let's say you save $30 on solving each task correctly, and then for the ones you don't, you incur like negative 100,000 over the course of them. So in some sense, I guess, like, I even sort of, when transferring to real world utility, I even doubt there is like this constant factor. I think right now it's strongly, strongly negative.
But do they become more negative as they become more powerful, or is there like, as the AI becomes better, does it at least become less negative?
Yeah, I think we'll have to look into that one, but perhaps.
Yeah, so I guess I would have said, my guess is that like C is like 3 or 4, So like as in I would have said like maybe AIs right now have like 2.5, 3 hour horizon lengths, and on like benchmark tasks with 50% reliability. And then if you go to like messy real world tasks they aren't particularly specialized by, I would guess their 50% reliability horizon length is like, yeah, like 3x or 4x lower. Now, that's not to say that AIs with 50% reliability horizon lengths are that useful, because maybe, you obviously can't just trust their output because they're only 50% reliable. And then Meter has results on 50% reliable versus 80% reliable, and they see it's also roughly actually a 4x multiplier there. Though it's kind of a mess because it's not that obvious that their benchmark is sufficiently reliable to measure high reliabilities. And so 80% reliability might be more impressive than it initially seems. Yeah, and I also think there's a specialization question. So I wouldn't be surprised if AIs are, for example, especially good at assisting with AI R&D due to like custom models or whatever. And then that maybe boosts you back up closer to the benchmark numbers, but unclear how much.
Two areas maybe well, I guess first, actually, on the meter thing. So you said earlier you predict in a year from now they'll be doing 8-hour tasks with something like 50% reliability. Would that imply that they'll be doing the 2-hour tasks that they're doing today at like 80 or 90% reliability? And then relatedly, one area of potential agreement that we didn't talk about is labor market impact. I'm just curious what your thoughts are on that in the near term.
So first, a simple question. Yeah, 20% reliable, like 80% reliability, 2 hours in a year or something.
Yeah, I think that sounds reasonable. I guess the one sort of caveat I would add is I think like reaching 99.999, like 5 nines of reliability is much, much, much harder than reaching, like going from 50 to 80.
I think you would agree with that.
I agree with everything you said.
And maybe like another sort of thing on top is to fully automate AI R&D, we might need to get to that level of reliability, or like to really do like a lot of the tasks at high levels of reliability, you might actually need things that are orthogonal to models
And that's why I
to
think
get that level of.
Yeah, I would also note that humans definitely, if you benchmark them in the same way as models, would have way less than 5 nines of reliability. And the way that we like have human institutions that work and whatever is via having like different things that like can like, check themselves and notice when things are going wrong, etc. And I would say like correspondingly, we have to be like careful that we're doing apples to apples comparisons here.
Okay, the second part of the question was about automation of the labor force. That was roughly.
Yeah, or like what kind of labor market impact do you expect to see in the next few years?
Yeah, like 3 years. Do you think that like most people are still employed like they are today?
Well,
Yes,
yeah, but like it doesn't have to be like extreme scenarios. I just mean like, do you expect that like you will see labor market dislocation that is noticeable?
So I definitely think we'll see some kinds of labor market impacts, or like things that are sort of isolated to a certain type of profession and a certain career stage. And in particular, not just because like AI would be so good at these things and that can automate tasks away, but also because of collective action problems. Like firms would not have incentives to hire entry-level workers for a number of things that they might otherwise have hired them for, because senior people can sort of use AI for that, but then you don't have a career ladder, and that'll be something that takes time to sort of fix. Whereas I guess maybe like Daniel and Ryan have more aggressive estimates. I don't know.
I don't think so. I mean, like in AI 2027, we had some lines about this where we were like, in mid 2027, the economists come out with a new study saying maybe they can see some impacts after all, or something like that, you know. And this is like, while the intelligence explosion is ongoing inside OpenBrain. So I don't think qualitatively we have any disagreement there. I will say, I think anecdotally, I occasionally like talk to people on the BART and stuff, and have had several conversations with people being like, oh yeah, we fired some engineers from my startup and now things are going faster. Thanks to Clyde or whatever. And then also there's an interesting study which you probably also saw it passed around on Slack or whatever, with the hiring for entry level programmers that seems to have gone down recently, and maybe that's because of AI. So
It's sort of on the uptick now. Back again, on the uptick.
Yeah, I think in 3 years, I do expect labor market effects, at least when localized within some sectors. Like I expect within like, software engineering to have substantial labor market effects would be my guess. I think in terms of like, does the actual unemployment rate go up? My guess is that it will be like hard to tease out the AI effect on the unemployment rate at that point, but maybe not hard to tease out the AI effect on GDP at that point.
Yeah, I'm curious what you guys agree on. Like for the part of the research engineering job of a 80th percentile, like frontier lab engineer, like not the ideation part, just like implementing things. Like what parts do you agree in the next couple of years, like an AI, let's say like tasks that take less than or equal to 1 day? Like, what percent of tasks, like, or what kind of tasks do you guys agree that, a model will be able to do or won't be able to do?
I think you're gonna say most of them.
Yeah, like I would. I'm uncertain about timelines, but it seems to me like sometime in the next 5 years or so, all of them will be being done by AIs.
I mean, I think a lot of the tasks would be done by AI systems, but I guess that is when we'll sort of redefine this redefinition of what constitutes this job will come to be, where the job will sort of actually, in some ways, it's already becoming much more about specification rather than actually writing the code. And so I think the hard part of the job will continue to exist and will continue to be done by research engineers, but it would have shifted from actually thinking about things and writing the code and so on to just being very specific about what you want and being able to control AI systems outputs to adhere to those specifications.
And going back to what you were saying before, as a result of this, people are faster because they no longer just spend their time typing at the computer. They're spending most of the time thinking. And you're thinking this speeds them up some, but maybe not a huge amount.
Exactly.
But I also agree with that, in fact. And 2027 talks about how they don't fire all their engineers. They just sort of, now the engineers are basically managing teams of AIs,
Do you guys have agreements on what kind of like ideation and like that part of the research job of a frontier lab engineer like the AIs will be good at?
My guess is we have some sort of disagreement there because
Let's return to that in
Yeah.
in a couple minutes. One more question.
This is a quick one. What is the first year you both agree on 1% U.S. GDP growth due to AI? What is the first year where you both say, yes, there's definitely 1%?
1% additional.
Yes, additional.
Or like more than 50%, or
1 additional percent in U.S. GDP.
yeah, but like with what probability?
I just pick a year, damn it.
so I would say that like
You're not really Bayesian. None of us really are. Pick a year.
I would say that like 2030 is the year such that there's a 50% or greater chance that there'll be 1% GDP growth due to AI in the US.
Okay. In what year will there be? And do you agree with that number? 2030.
I think it's plausible. Very hard to predict the future.
Okay. What year will be $2 trillion in AI revenue?
Wait, in revenue?
Yes.
I don't think you can see that far. Sorry.
Reasonable.
I think this is basically going to be like either like a year before or a year after AI is fully automated AI R&D, unclear which side, or like roughly around there. And so I guess my median would be like more like 2034, 2035 for that. But low confidence.
Okay, I think this is roughly where we want to stop for time. We're going to finish this. Yeah, thank the speakers.